evening, everyone. This is Shankar from EC department. Today I am telling about the signals and systems seminar. My topic is Fourier transform from the Fourier series and the Fourier transform of the singularity functions. Let we discuss. Introduction for the Fourier analysis. In engineering relevance, Fourier analysis from the mathematical foundation of the signals processing control system and communication engineering. It enables the engineering analysis complex waveforms by decomposing them into the similar sinusoidal compass of the components. First, the classification of the signals are two types. There are periodic signal and non-periodic signal. Periodic signal repeats the over the fixed intervals, and the non-periodic signals are do not distribute the functions in the respective patterns. And next, Fourier series of the fundamentals. What is the definition of the Fourier series? Mathematical representation of a periodic function as the infinite sums of the harmonical related to the sinusoidals. And the standard formula is x of t is equal to summation n is equal to minus infinity to infinity cn e power j n omega naught t. And their applications of the Fourier transform series are signals representation, harmonic analysis, and system designs in the electrical engineering. And where cn is called as the fraction of the Fourier series. And the omega. Next. Next, extending of the non-periodic signals. First one, periodic extension. Periodic extension means consider what happens when the periodic time is approx infinity. Is called as the periodic intention. And second one, frequency spacing. A frequency is to infinity of the frequency spacing omega of the fraction of 2 pi of omega t. T is equal to time period. 0 is equal to omega. And 3. Discrete and continuous. The discrete frequency of the spectrum of the continuous spectrum of the discrete signal from the integral, the summation of the discrete frequencies of the integration over continuous of the frequencies and the discrete continuous periodic extension, frequency spacing, and discrete to continuous sum of the integrals. Next one, derivation part of the summation. Starting from the Fourier series. Fourier series formula is x of t is equal to summation n is equal to minus infinity to infinity cn e power j n omega naught t, and where cn is equal to fraction of t integral minus infinity to infinity minus t by 2 to t by 2, and x of t is equal to e power minus j n omega naught t, where defined variables are omega is equal to n and the substitute into the coefficients of the expression. Rewrite the expression. And x of t is equal to summation n is equal to minus infinity to infinity 1 by t integral minus t by 2 to t by 2 x of tau is equal to e power minus j omega t d tau, and in the e power j omega naught t. Next, derivation part 2. Applying the limits. Multiply and divided by the omega. X of t is equal to summation n is equal to minus infinity to infinity 1 by 2 pi integral minus t by 2 to t by 2 x of tau e power minus j omega naught t dt is equal to omega naught e power minus j omega t. After applying the limits, our equation is x of t is equal to summation n is equal to minus infinity to infinity 1 by 2 pi minus t by 2 to t by 2 x of tau e power minus j omega naught t d tau omega naught e power minus j omega naught t. Take the limits on the intensity infinity to 0 to 1. Sum of the becomes integral. X of t is equal to 1 by 2 pi integral minus infinity to infinity double integral minus infinity to infinity infinity to infinity x of tau e power minus j omega naught t. Next, this is the expression and representation of the Fourier transform of the formulation. Forward transform. X of omega is equal to minus infinity to infinity x of t e power minus j omega naught t dt, and converts into the frequency domain. And the inverse transform. X of t is equal to 1 by 2 by integral minus infinity to infinity x of omega is equal to e power minus j omega naught t d omega naught t. In the representation of the domain and the frequency domain, key the discrete spectrum of the periodic signal becomes as the continuous through limiting process. This is the forward transform and inverse transform. These are the two types. And x of omega is equal to minus infinity to infinity x of t e power minus j omega naught t dt. And inverse transform. X of 2 pi is equal to minus infinity infinity x of omega is equal to e power j omega naught t d omega naught t. Next, properties of the Fourier transform. There are four types of properties: linearity, time shifting, time reversing, time scaling, frequency shift. What is linearity? Linearity means ax1 of t plus bx2 of t and equal to ax1 of omega plus in terms of represent of t and omega. T means time period, omega is equal to frequency and the time shifting. X of t minus t naught is equal to x of omega e power minus j omega naught t dt. Next frequency shift. X of t e power j omega naught t x of omega minus omega naught. Scaling. X of at is equal to 1 by 1 1 by xa is equal to omega by. These are the properties of the efficient of the enabling complex signal from the system in the engineering application. These are the properties of the Fourier transform. Next, singularity functions. What are the singularity functions? There are Dirac delta function, unit step signal, ramp function. This is the representation of the singularity functions in the mathematical definitions. X of del of t is equal to 0 to infinity to t is equal to 0 and 0 to infinity with the integral minus infinity to infinity delta t of t into dt is equal to 1. In the unit step signal, there are u of t is equal to 0 to 1 and t less than 0 and 0 t greater than 0. The lamp signal are r of t is equal to t in t u of t and the t. Next one. Conclusion of the all applications. Signals analysis, control system, communication. Signals analysis means Fourier transform enabled to frequency domain and analysis of the frequency domain with analysis of the signals, revealing of the spectral contact of the filtering characteristic essential for the digital signal processing. And next, system stability and performance. The analysis replay of the heavily of the frequency domain techniques derived from the Fourier theory for the robust control design. In communication, communication is the modulation, demodulation, and channels analysis and signal analysis, wireless of the optical communication system from the depends on the fundamentally on the Fourier transform in the principles. The transition from the Fourier series to Fourier transform bridges the gap between periodic and aperiodic signals, formation of the mathematical foundation for the modern applications of the system. This is about the Fourier transform and Fourier series in applications of 2. The transformation of the Fourier series and Fourier transform bridges are gap between the periodic and aperiodic signals and causal and non-causal and other types of the there and analysis from the mathematical foundation. The modern engineering applications are the signal analysis, control systems, and the communication. This is about the conclusion. Next, the last step is the transformation of the Fourier series and Fourier transform bridges gap between the periodic signal and aperiodic signal, forming the mathematical equation foundation for modern applications. This is about the Fourier series and Fourier transform. Thank you.